Okay, cool. So what we will learn now is, so whatever we have learned earlier is like you processed a string, right? Now we will process a number. Now every number can be represented as a bits, right? Zero and ones.
Hmm.
So the next concept which we will learn is bit trie. Same question, ठीक है क्या? Say that, okay, uh, okay, maybe there are some numbers 5, 3, 2, 7. Okay, there are these numbers, right? So what we need is we need to insert them into a trie. So first let's tackle how can we insert numbers into a trie data structure. Okay, so what's 5? Correct, in binary 101, right? What's 3?
010 011
2,
010
7.
1 111
अरे इतना टाइम क्यों लगा भाई तुम्हें 111 बोलने
पता
में?
नहीं अरे आदत नहीं है इसका इसके लिए
ओके, सो अगेन विल स्टार्ट विथ रूट नोड ऑनली. ठीक है मनन, अपन रूट नोड से स्टार्ट करेंगे. ठीक है, अब क्या है पहला?
1 0
सेम स्टोरी
1
मैन, सेम स्टोरी, नथिंग एल्स. ठीक है, 101 इस पे कुछ ना कुछ लगा दो. 0. व्हाट्स द नेक्स्ट वन? इज द ट्राई क्लियर गाइस?
Yes, bro.
या
Quick yes. Sam, did you understand? Isn't he available? Sas is not there.
मे बी इट्स नॉट रिस्पॉन्डिंग
Is not responding, right?
Yeah, he's there in the class, but
Okay, cool. So did you, Manan and Sas, did you guys understand ये वाला structure?
yeah, understood.
Okay.
Yeah, understood.
So see, there is only one thing that now हम लोग तो अभी 3 lengths में we wrote, right? But we don't know
Mm.
how many length it will be. So what we will do is, for integer we will start with 31 bits. For long we will start with 63 bits every time. Okay. So I'll tell you what to do in that case.
Okay.
So before that, let's start creating the bit trie. Okay, bit trie, bit trie intro class bit node. Okay, so in this case what we need, can I say I need only 2 length array? I, because there will be only be 0 and 1, right?
Correct. Instead of map.
Exactly. मनन समझ में आया? सिर्फ सिर्फ 2 ही लेंथ क्यों लिया मैंने?
0 और 1
Exactly. So array of 0 is null. I mean, it will be null, but I'm making it explicitly as null. Okay. So since there will only be 2 length, 0 and 1, we kept it like this. Yeah. Okay. So since there will only be bit 0 and bit 1, we have this ready. Okay. Now class try for bits. So same stuff, right? Initially, what we will have? Root constructor, constructor में this dot root equals to new bit node. Now, what we need to support insert functionality, right? So, okay. Now, what do we do? Node cur node equals to root. We always start from root. Okay, bit node. This is bit node. Now, what we do in this case is we fix the bits. Okay, so for integer at max there can be 31 bits, right? Correct. Integer पे 31 bits होते हैं ना?
Yes.
Hey, what's us?
Yeah.
Now
Sorry, I was on mute. Yeah, yeah.
okay, so private final max bits equals to how much? 31 bits.
Hmm.
Okay, so for int I equals to max bits. So what we do is we process from uh, like 31 bits. Okay, I equals to 0, I. Now, how to check whether a bit is set or not? Who can tell me this?
Left shift.
पूरा बोलो. I want to check for a number n whether ith bit is set or not.
N and n minus 1.
Wrong. Okay, n and n minus 1 what? Yeah.
Yeah. Okay. Like
X
and
and
Okay,
left shift of that.
one left shift of I.
n and
One left shift of I is greater than 0.
can I say this? Agar one left shifted of I is greater than 0, that means the bit is set, right?
Yes, yes.
Yes.
Okay. Now, so simple. If cur node dot what is the AR of bit if equals to null, what we need to do? Cur node dot AR of bit new bit node. Make sense? Same thing as in a trie data structure. If it does not contains a key, so here if it is a null, please assign a new bit node. Okay, and finally we need to go there. So clear?
Yes.
Okay, and this is what we have for the insertion of any number in a trie data structure using bits. Clear है? Insert function. Sahas, Sam, Manan. Are you guys clear?
Yes.
Yeah,
Yeah.
clear. Bro.
Oh, okay, cool. Okay, so insert functionality is done. Okay, now probably like we should take some questions. Okay, uh, okay. So what we'll do is we'll try to solve one question. Okay, yeah. So let's say you are given Q queries. You are given Q queries. In Q queries, there will be three types of queries. Okay, the first type is add x, that is add the number x to your set. The second type of query is remove x, that is remove x from your set of numbers. Okay, third query is given a number x. Okay, given x, you need to, so whenever you are doing addition, that means you have some set of numbers with you, right? A, B, some numbers available with you. Okay, so given x, what you need to do is you need to find out of all the numbers which number I pair with x so that it gives me maximum XOR. Okay, out of all the numbers you should pick a number which when combined with x, I mean when you do XOR with x, it should give the maximum answer, maximum value. Is the question clear or should I repeat again?
Yeah, got it.
Okay, so you you will be given three types of queries. Add x, that means take x into a set, remove x, and remove x means the number will always be there here. Okay, so you should remove x from the set. Third query is given a number x, you should find some number from here such that it should give you the maximum bitwise XOR. Okay,
Yes.
so brute force, can everyone do brute force?
Yes, bro.
So what data structure you will keep for root? Is set enough for us?
Yeah.
Yeah.
Set enough, or is set a wrong data structure? Hey,
If we keep
someone,
set, yes, sir.
so is set enough for this problem?
If we keep add x may set will work.
Correct. So if I say add 2, so there are two twos. If I say remove 2, since set will have a unique maintenance, it will remove that 2, but you have one more 2, right?
Hmm.
ये set तो नहीं होगा.
uh, okay.
तो map, what do you think of map? Map is fine, right? Addition, removal.
Yeah.
Yes, maintaining count of it.
Exactly. And finally, for this third type of query, what you will do? You will iterate on all the map. Which one is
Hmm.
giving you the best answer? You will take that.
Correct.
But again, this has a lot of overhead, right? Because the overhead is not an add remove. The overhead lies in this third part where you have to travel the entire map, right? And since the numbers can up to 10 power 9, you have to travel all the, let's say in the worst case, you have all the 10 power uh, 9 numbers in the map, then it will just break. I mean, you won't pass in 1 second. So what can we do? Okay, so I'm just going on to the solution because the bit tries we are learning it for the first time, right? So do you see that whenever we are creating a node, it's totally up to us what are the structures we need to keep, right? Remember, in the last question also, which is given as a homework, we are storing index in a node, correct? So
Hmm.
can we also store a count means kitne numbers hai which has this bits, I mean which has gone through this. Okay, so let's say I tell you the numbers are the same numbers, 5327, right? So the 5 is this side, this is 1, this is 0, this is 1. So as soon as we are going, can we also maintain a counter? Counter means how many numbers have these bits like this. Okay, so plus 1 plus 1 plus 1 initially. The next number is 3. What is 3? 0 1 1, right?
Hmm.
So 0 1 1. The next number is 2, right? So what's 2? 2 is 0 1 0, let's say.
Yeah.
Now as soon as we see from root node, there is a 0 already available. So if we go here, the increase the counter by 2.
Okay.
Okay, now next is 1. So 1 is already there, so increase the count by 2. Next is 0. 0 is not there. The last number is 7. 7 is 1 1 1, right? plus 2 because
2.
is it clear? Is this part clear?
Yes.
Yes, bro.
Now see
Yeah,
the
clear.
now see the trick of removal. Let's say I want to remove 7. What I will do? Now let's say I want to remove 2. Okay. Now
Okay.
here, go here, decrement now. Because if you have incremented, you should decrement now, right? Because you are removing.
Mm.
So
Yes.
0, the next is 1. Next you will go here.
0.
So now you see we are only traveling through this try easily. I mean, the removal is not a problem for us now. Okay.
Yes.
Once this structure, now this structure supports addition and removal in a very easy manner, right? What
Mm.
about finding the numbers? So say I give you the number 4. Okay. So out of all these numbers 5327, okay, assume that 2 is not been removed now. Okay, you can assume that 2 is not been removed. Out of 5327, if I give you the number 4, which is 100, which number we should XOR with so that we'll get a maximum?
3. 3.
Now how you are able to tell very quickly, because I mean, obviously it's a visual, but let's, so do you remember the basics? The basics of XOR is try to construct the answer bit by bit. You remember we
Mm.
learned this technique, bit by bit contribution. What is 4? 4 is 100. So
Mm.
what is the better suited for this? The, I mean, should we keep
Opposite of
exactly
it.
opposite, right? If it is 1, I should go to, if it is
0.
if it is 1, I should go to 0. So from
Mm.
here we will start. Let's check whether there is a 0 or not. Yes, there is a 0 available. Please go there.
Okay. Mm. 1.
Yes, there is a 1 available. Please go there.
Mm. Next also 1. Okay.
Okay. And let's say
Mm.
we have maybe 0, 0, I don't know, 010. Okay.
Okay.
Okay. Or maybe 110. Let's keep this. Okay. So Manan,
Mm.
uh, for fun, where should we go?
0.
तो इधर चले गए. ठीक है.
Mm.
For 1 again we need 0, but do you see any 0 here?
No.
If there is no 0, is there any possibility that I can keep 0 here? No, right? So
No.
which there is only one path, which is go to 1 only. So इसमें भी 1 लगा देंगे अभी. Now we are at here. What is the next bit? 0. So we need,
0.
is there a 1 available? I see yes.
Yes.
So please go there and keep. Okay. So did you understand this? What we did? Okay. I
Yeah.
mean, try is
Yes.
not hard in a very. I mean, these are the medium level questions. Or the medium hard questions will be in this manner. I mean, if you go to hard, obviously there will be some hard means what? You should use some additional data structure. In this node only, you should maybe store some other information. Okay. So, but yeah, we understood what are the fundamentals, right? That okay, there is this node and what we need to store, right? So yeah, so let's go and let's start writing the code. Okay, so now can you see instead of ARR we also need something which is correct.
Yes, bro.
Okay, so whenever I am inserting, whenever I am going to new node, can I say this?
Yeah.
Yes.
समझ आ गया सब इस लाइन?
Yes.
Did you understand?
Yeah, got it.
Public void, okay, move, क्या करना है? Same code, copy paste. So let's say assume that they will always tell remove a number when it is all, I mean it will always exist. Okay, so here done. To
Yes.
remove means we have to decrement the count, right? That's
The
it.
font.
Okay. Now finally public long or int. Okay, long find max. Okay. Okay. Long answer. So we need to return this answer. Okay, what's the maximum XOR value? So what we do again, let's take this same level of code. Now I'm just copy pasting most of them because everything repeats same, right? So now we have the bit value, right? Whether it is 0 or 1. So can we just differentiate between two cases? Okay, if bit equals to 1, else. Okay. So if bit is 1, what shall we try to take? I mean, what is
Zero.
optimal for us?
Zero.
0, right? So if current node dot array
Get.
of 0 is not equals to null,
Hmm.
and current node dot array का 0 dot count,
Greater than zero.
in that case can I say the answer, the particular bit, I mean the highest bit of the answer will be set because you will always have one.
Yes. Yes.
So how to set a bit? How to set a bit? I taught you probably.
With or.
Yes. So answer equals to, okay, this is the meaning of setting a bit. Okay. So if we have 0, where we should go? We will obviously go to 0 only, right? Else,
1.
ये कॉपी करो, उठाओ, पेस्ट करो. So else में you know, right, it's a reverse, that's it. So if we are at 1, we should, I mean this is bit 1, so this is bit 0. If it is a bit 0, can I say
1 is.
हो गया?
Yeah.
So did you guys understand this else part or not?
Yes.
Saz,
Yeah.
Yeah, clear.
Understood.
Sam, you understood, right?
Yeah.
Okay, chalo. So I guess this is it. I mean, okay, obviously we need to return it. Let's, okay. So what? Scanner int query. While query minus. Okay. Okay. So what we have string type. Okay. It is add, remove, or whatever. Okay. So if type dot equals add, we need to obviously create a try also, right? Try for bits. T equals to new try for bits. If type equals to add, that means we need to, let's take a number outside only because for each of them we will have it, right? Okay, if type equals to add, what we need to do? T dot
Insert.
else if type dot equals, अगर remove है else is it fine?
Yes.
Yes.
Okay, so yeah, let's start. So we will give 7-8 queries. Okay, so let's first add everything. Okay, so maybe 7 add, and what shall, okay, let's take this example itself, 5327. Okay, so we will add 5, add 3, add 2. Now what we need now, we need to, we will find the maximum, and then uh, we will remove one number and we will find the maximum again. Okay, so not remove, uh,
Find.
find here. कौन सा नंबर लेना था? 4. You remember we took 100, we took right somewhere.
Yes. Yeah.
Are we seeing that we are getting 7?
Mm-hmm.
Yes.
Now let's remove 3 and let's see. Okay, remove 3, find 15, and now we are getting it as 6. Okay, so if you see, out of 5327, 2 के साथ it got removed, right? So we have 4 as 100. So with which number it will get paid?
011 only, right?
Oh, sorry, we removed 3, right? We removed 3 now. If you see, we removed 3.
Yeah, yeah. So it should pair with 010, right?
Should
No
pair
one.
with 010. And the answer is 110, which is nothing but 6. And did we get 6 here?
Yes, yes.
Yes.
Okay, so this is how. So Bittry is generally used for solving XOR problems. Okay, whenever you have a XOR problem, अगर तुम लोग को, if you are not able to think of something in brute force or this or that way, one thing should immediately strike into your mind is Bittry.
Like they will ask directly XOR or any other terminology. Like
See, easier questions I am directly solve. Harder questions, you remember in bit we solved one problem. The question was something, remove 2 power k, 2 power k, and
hmm.
then we somehow finally boiled down that problem into find number of XORs which have a value equals to 0. If you remember, we have solved that question in one of the discussion.
Okay.
You remember that 2 power k?
I am not able to recall exact question.
See, this is the difference, right? That's what I say. Okay, anyway, but you guys understood, right, what we did here?
Yes, bro. Yeah.
Especially this one, find max.
Yeah.
क्या है, bit 1 है कि bit 0 है? अगर if the bit is 1, check whether we have the 0th bit or not. If there is a 0th bit, we always know that the answer will have this as a set bit. Set
Mm.
to 0, otherwise go to 1. Similarly, if bit is 0, check whether we have bit 1 or not. If we have, we know in the answer there will be a bit set. Go there, otherwise go here, and finally return.
Also.
Perfect, clear?
Yes.
Chalo. Let's do one more problem on this. Given an array, find the max XOR subarray. I mean, find the maximum value of this. I mean, max like how we say max XOR of a subarray. Okay, you understood the question? Or how we have maxsum in cadence, similarly max XOR.
Mm.
Okay,
Okay.
given array, find the subarray which has a maximum XOR.
Yeah.
Okay, so think of it for a couple of minutes. Quick question: given an array, what's the maximum bitwise AND?
Small bit and
Yeah, what's the maximum bitwise AND? Which subarray will give me the maximum bitwise AND? Array, if you are thinking that much means bits are not clear. Sam, what we learned in properties of bits, if we combine the numbers, maximum bitwise AND will decrease or increase?
Bitwise and should decrease or should increase.
Correct, right? So
Yeah.
can I say the number which is having the highest value, that is the only subarray which will give me the maximum bitwise AND, in this case 9,
Yes.
because
Yes.
if I combine with any number, it will always decrease, right?
Yes.
And what will
Yes.
be the maximum? Or
Sum of all.
yeah, I mean sum means or of all this subarray.
Yes. 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 Hmm.
समझ आया? साहस है?
Yes. Yes. We
Yeah, yeah,
discussed in
understood.
the discussion.
Okay, so now the question is, find the subarray, I mean find the maximum value, I mean find the subarray which has a maximum XOR value. So in this case probably like 43100011, so it has a value of 7, so or maybe 9. Yeah, I mean there will be some subarray which will give the maximum answer, so I don't know which one it is, but by program we can calculate it. But anyway, so what can we do for this problem? Okay, hint, brute force, is brute force
generate also arrays. Find
जनरेट
subarrays.
वेनरेट करने का नहीं है, टू फॉर लूप्स लगाओ खत्म. जनरेट वेनरेट क्या करोगे? जनरेट मतलब ऐसे ही बोल रहे हो ना, 1 2 1 2 3.
हाँ.
हाँ वही तो, जनरेट मत बोलो. सो लाइक ठीक है, जनरेट यू कैन से. एनीवे, मतलब मेरे को जनरेट मतलब कैसा दिखता, मतलब यू शुड जनरेट एंड देन कैलकुलेट, ऐसा दिखता है.
Okay.
ओके, एनीवे, सो टू फॉर लूप्स everyone can do it, right?
Yeah, yes, bro.
But how about finding the better answer? Hint is prefix or.
Using formula 2 power of k is greater than 2 power of k minus 1. That one. Helpful.
Okay, but how will you use it? let's see. I mean, yeah, if it's first time, it's hard. I mean, unless you see the techniques and all, it's kind of difficult. But okay, assume that this is a optimal subarray. That is, this will give the best value. Okay, which is I. This is j. What did I just mention? I mentioned that prefix or, right? Correct. So what's the prefix or till here? Till A to F. So do you remember we can write prefix XOR till 1 XOR prefix XOR from here to here. I mean, the XOR of this part with the XOR of this part will give the total XOR of this A to F.
Yes. Yes.
Prefix XOR of A to F is nothing but prefix XOR of A to B
A B.
XOR prefix of C to F.
CF.
Hmm.
Correct? What we are claiming?
Hmm.
The claim is C to F is a perfect answer. Correct? If that's the case, okay, can I take this part here into LHS?
Yes. Yes.
So can I say P of A XOR F, I mean A to F XOR P of A to B is equals to P of C to B, C to F, sorry. How many of you think this expression is true? A equals to B XOR C matlab
Yeah. It's,
C equals to A XOR B. We remember, right? We do that technique XOR on both sides.
Yes. Yes. Yes.
Manan, expression clear?
Yes, yes.
Okay. So what we assumed is this is our optimal answer, right? Since we are processing at F, can I say this will be there in my, this will be readily available for me? A to F. We can maintain a running XOR, right? A to maintain,
yes. Yes, bro.
right? P to A to F we can
Hmm.
maintain.
Hmm.
The question
Correct.
remains with which number, I mean with which, if I have to speak precisely, with which prefix XOR, with which prefix XOR if you do, the number should be, the number is maximum. Is this the question or not? The question, I mean, what we claimed is C to F is an answer. If C to F is an answer, then this part should be as maximum as possible, right? थोड़ा maths के term में I'm telling you, if C2F
Yes.
is
Yeah.
an answer, in order to be an answer, the left side expression should be as maximum as possible, correct?
Yes.
Can I say P of A to F is readily available with me? Readily means I am running, I am at F only, so I have the XOR P of A to F. The only part which is not there with me is A to B, right?
Hmm.
So is the question same as the previous question only? Given a number, find out which number it will give the maximum XOR. Because if you see A to B is this prefix only, right? So can we insert this into a trie data structure and calculate? We will insert A, AB, ABC, ABD, ABE, and out of all them, which one will give me the maximum one? Can I say that is the maximum answer? I mean, at this position. No? Okay.
Once again,
Where is the part which you didn't understand, Sam? First you tell me.
like we'll be storing that in the tree.
Try. Yeah.
Yeah. Try. Sorry. Like from there, how we will be getting this
Yeah. Wait. So
P of
Sam, what we assume this is the answer, right?
yeah.
Okay. Can I say P of A to F is available with me?
Yes.
Can I say this is nothing but some prefix only?
Yeah.
A to B is one prefix, right?
Hmm.
So if this is the number given to me, can I say I should find out of all the prefixes, which number is giving me the maximum value? I mean, this expression is giving me the maximum value.
Yes, yes.
Can we, is the problem same as this problem only? Third part.
Okay.
Given a
Yes.
number x, which is nothing but this one, this is x.
KPF.
Find out all the numbers which are there in the set. In our case, it is a try, which is giving me the maximum answer.
Yes, yes.
So
Okay.
if I do here, can I say I am done? If I do for
Okay.
all of them,
Yeah.
समझ आया? I mean, I guess you should understand at this point.
Yeah, got it, bro. Now I got it.
What about others?
So in this case, B is nothing but the given value, right?
No, that is what we assumed. A, B, obviously A, B, these are the numbers given. Okay.
Yeah.
I am saying C to F is an maybe it can be some other also, but the expression is boiling down to this only, right?
Yeah. Yes, bro.
Exactly, right? If we are assuming C to F, then P of A to B XOR P of C to F is nothing but P of A to F, right? This is the first expression.
Yes.
If we rearrange the terms, we can get to this expression. As per our conclusion, C to F should be an optimal answer. If C to F should be an optimal answer, okay, this value should be as large as possible, correct? If this value
Yes.
has to be as large as possible, I already have A to F ready with me. The only thing which I have to find out is which prefix will give me the maximum value. So is the
Yes.
question same as third question of third query?
Yes.
Given x, find out the maximum number which is giving me x.
Correct.
Is the concept clear?
Yeah.
Okay.
Yeah.
This is how we solve prefix type of problems. Okay. So assume that there is this optimal answer exists, write some condition, bring down the variables which you have, and in order to get this, we have this ready. We have this one ready. So out of all which we have to find this number. Okay. Sure. So क्या करेंगे? कुछ नहीं. I guess we have already the things available with us, right? So I don't need to do anything else. I am just commenting this out. And int n equals to sc dot next int. Okay, so we will have an array, right? So let's quickly take down the numbers. Okay, int prefix XOR. So int max answer equals to a of 0. Let's assume that the 0th element is giving me the maximum answer. Okay, and prefix XOR is this. So for the first element, the prefix XOR will be that number only, right? That's the reason. Okay.
Yes.
P dot insert pre-XOR. Okay, for int I equals to 1, I less than n, I plus plus. Now, can I say max answer is nothing but mat dot max of, I mean whatever you have earlier, comma t dot, can I say this now?
Okay.
This is
Yeah, because all max.
इसको change करो. Okay, so is this clear, this line? Key, we have
Yes.
prefix or available. Okay, so I am doing it. Okay.
Okay.
So obviously I need to do this also, no? Matlab prefix or is still I, right? Yeah. And once done, can I say? Can I say this?
Update.
I mean, you need to insert the another XOR, right?
Yes, bro.
Out of all of them, someone would have definitely given me some answer. it. No change in the code. Only this. This is what logic of.
Okay.
Chalo, let's see. Yeah, chale, we'll take 1, 2, 3, 4, 9, 6. Okay, 6 length, 6, 1, 2, 3, 4. The answer is 50. प्रूफ कैसे करना है? 15 है.
होगा कैसे करेगा
0, 1. I don't know. Okay. So, do you want me to verify whether this is correct or not?
no
Yeah, बोल दो भाई. I'll do it. I'll write a
नहीं
blue.
नहीं
Yeah. So, this is normal brute force, right? Current XOR equals to P of I. Okay. So, for ma equals to max of ma comma current XOR. We'll write a loop for j equals to j plus 1, j less than j plus plus. Okay. Current XOR equals to P of j. Repeat this command.
yes done.
Good.
assert क्या है रे
Okay, let me write this. ma equals to max answer. यही आना चाहिए ना?
Mhm.
yes
Perfectly good.
Okay.
yes yeah
Clear?
yes
Yeah. So this is a bit wala stuff. Okay. So see, you got the fundamentals. Now it's all about how you modify the structure, how you keep more information in order to extract whatever you want. Okay.
yes
Okay.
So this marks
nice
the end of your